Hello, my dears. Today we are looking at atoms and the periodic table. By the end of this video, you should be able to describe and label the parts of an atom and identify how to determine the number of subatomic particles using the periodic table. So let's go ahead and get started. Okay, so we have talked about atoms a little bit in the past, but we really haven't taken many notes on them or dived very deep. So what is an atom? An atom is the smallest particle of an element. Everything that's matter is made up of atoms. So everything that has mass and volume is going to be made up of atoms. Atoms join together to form something called molecules, which is probably a term you've heard before, but we're going to dive deeper with that later. Now, every atom has parts, and we call those parts subatomic particles. There are three types of subatomic particles. The first type is the proton. The proton is a positively charged particle that is located at the center of the atom. So you can see in our little drawing over here, all of these little pluses. Those are protons. That area is called the nucleus. And so it's located in the nucleus, and it has a mass. So again, that's part of what makes it matter. It has a mass of 1 AMU. Now, this is kind of a weird mass unit, right? Usually when we talk about mass, we're talking about like kilograms, or grams. But the thing is that an atom is so small. So 1 AMU is equal to 1.66 times 10 to the negative 27 kilograms. So I'm not sure how much you've gone into like scientific notation in math yet, but you can see here, this is a negative number, negative 27. So what that means is that you would move the decimal point here over this way 27 times. So that's going to be equal to a number that's like 0.000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000Now, sharing the space of the nucleus by just saying 1 AMU. Now, sharing the space of the nucleus is, along with the protons, is neutrons. Neutrons have a neutral charge. We talked about this a little bit before, but remember, that means that they have no charge. So positive proton, right? PP, positive proton. Neutron, though, you have to think of that like first part, neutral, right? So it has no charge, but it does still have a mass. So what that means is the more protons and neutrons, the more massive your atom is going to be. Lastly, we have electrons. Electrons are not in the nucleus. Electrons, you'll notice, are surrounding the nucleus here. And these are negatively charged. And the area that they spin in, that is referred to as the orbital. So these areas here and here, right, these are orbitals. So you have the nucleus in the middle, and then you have the orbitals surrounding the outside. Now, like I mentioned earlier, atoms make up elements. Elements are pure substances that only have one type of atom. The type of element depends on the number of protons, neutrons, and electrons. So depending on how many subatomic particles there are, that will determine what type of element you have. Some examples of elements are things like gases like oxygen, helium, neon, things like solids like gold, calcium, silver. There's not a ton of liquid elements, like elements that are naturally just in liquid form. But like one example of that is mercury. Now you can see over on the side, I have a couple sample elements to kind of show you what these look like. So helium is here. And you can see that helium has very few protons and neutrons in the nucleus, and also just has a couple of electrons going around the outside. By comparison, if we look at gold, gold is right here. Okay, you can see that the nucleus here looks a lot more crowded. You have way more protons and neutrons, and you have a bunch of electrons surrounding that in the orbitals. And then we have mercury here. right? So you can really see how the number of subatomic particles, protons, neutrons, and electrons, determines the type of substance that you have. Now, we use the periodic table to basically list out the elements that we know about. And we're going to zoom into one of these elements here to kind of see the parts of it on the periodic table. So each little square on the periodic table has different information. There's the atomic number, the element name, symbol, and atomic mass. When we say atomic number, that's the same as the number of protons that are in the nucleus of the atom. So carbon, if we were to look in the nucleus, we would see that it has 6 protons. The element name is usually like a Greek or Latin name for the element or a substance. So that's why they sometimes have really weird names. You also have the symbol. That's an abbreviation. So you can see here the symbol for carbon is C. That's just so that it's easier for us to kind of work with the elements and like kind of write about them. And then lastly, we have the atomic mass, right? So again, like how much matter is making that thing up. So that is located here at the bottom. So if we go back to our periodic table for a second, you'll notice that each of these, 1, 2, 3, 4, 5, 6, etc., right? These are listed in order of their atomic number, which means that these are listed in order of the number of protons. So as you go up, so for example, over here, 118, this element has 118 protons, whereas hydrogen over here only has 1. Quick pause for a joke. Do I know any jokes about sodium? Nah. So actually Na is the atomic symbol for sodium, because if you look at I think it's either Greek or the Latin root for sodium, but it's Na. So that's why it's funny. All right, now a couple of quick last things before we move on. Trick for finding number of neutrons. So I mentioned before that this number here, that's your atomic number, that is equal to the number of protons, okay? This down here is your atomic mass. This does not tell me how many neutrons I have though, right? It only tells me how many protons I have and the total mass. But remember, protons have a mass of 1 AMU, neutrons have a mass of 1 AMU, and electrons have no mass. So if I want to figure out the number of neutrons in an element, this is the trick that you can use. You are going to take the atomic mass minus the atomic number equals the number of neutrons. That makes a lot of sense because your atomic mass is, remember, both your protons and your neutrons combined. So if you minus the atomic number, which is your number of protons, then that is going to give you your number of neutrons. So in the case of oxygen here, and you can round up your atomic mass, that's totally fine. So in the case of oxygen, I would take 16 minus 8 equals 8 neutrons. Now, what about finding the number of electrons? This one's really tricky, so watch close. Remember again, this number up here, this is your atomic number. This is equal to the number of protons. Your number of electrons is equal to your number of protons. So whatever your atomic number is, right? 21 is the number of protons. That's also the number of electrons. That's how you find the number of electrons.